Okay, so today's lesson, we are moving on with Unit 3. This is the second half of Unit 3. So this half considers matrices. So we're going to talk about in this lesson what a matrix is and how to perform operations with them. So from your vocabulary, a matrix is a way that we organize data, all right? So matrices, they look kind of like a table, but they're not quite a table. So it's a rectangular arrangement of rows and columns that helps us organize numbers, okay? So we're going to talk about how to deal with matrices. So the first operation we're going to talk about is adding and subtracting matrices. So to add and subtract matrices, they both have to either be 2 by 2 or 3 by 3. They have to be the same dimension. So you add or subtract the corresponding elements. So if you look at this matrix, this first one, A and E are in corresponding positions, all right? So they are corresponding elements. So I'd add those together. So the idea is they have to be the same dimension. They have to have the same amount of rows and columns to be added or subtracted. So in example 1, when we look at adding or subtracting these matrices, in part A, the first matrix is considered 2 by 2. The second matrix is 2 by 1. So these do not have the same dimension, so we can't subtract. So I would say something along the lines of, we can't subtract because these matrices have different dimensions. Or different dimension, however you want to say it. But 2 by 2 means 2 rows, 2 columns. 2 by 1 means 2 rows, 1 column. In part B, now these matrices, they are both 3 by 2 matrices. So it is possible to add them, okay? So I'm going to write this kind of showing my work, and then I'm going to show the final sum, okay? So I would add -2 and +1. And then 1 plus -4. So that's my first row. My second row, 0 plus -2. So these two elements. And then 3 plus 9. My last row, 7 plus 1. And then 6 plus 5. So it looks a little messy, but it helps us kind of organize things. So my top row is going to be -1 and -3. My second row is -2 and 12. And then my bottom row is 8 and 11. Okay? So I had a 3 by 2 and a 3 by 2. My result was a 3 by 2 matrix. Okay? The next thing we're going to do is we're going to multiply a matrix by a scalar. So a scalar is a constant value that we multiply by a matrix. So essentially, when we multiply, like in part A, a matrix by a scalar of 3, that just means you multiply all of the elements by 3. So what this would look like is 3 times 0 is 0, 3 times 2 is 6, 3 times -7 is -21. That's my top row. Bottom row, 3 times -1 is -3, 3 times 6 is 18, 3 times 4 is 12. So you just multiply all of the elements by that scalar. So in this next example, part B, 2 times -1 is -2, -2 times 0 is 0, -2 times 3 is -6, -2 times -5 is +10. So it's multiplying each element by that scalar. All right? So moving ahead, guided practice. I have a subtraction of 2 matrices, and then I have a matrix multiplied by a scalar. So this is a chance for you to pause the video, work through each of these operations, and then once you're ready to move on, we're going to talk about some of the properties of these matrix operations. Okay, so for the guided practice, it's subtraction. So you could do, plus and negative for each of those elements, but I just kind of thought -6 minus 3 is -9. 2 minus 0 is 2. -1 minus 7 is -8. -5 minus -1 is like -5 plus 1, so that becomes -4. In number 2, I just multiplied each element by -3. So those are my elements of my new matrix. So I've got one more example or two more examples to show you. But matrix operations, this is just showing that matrices, when they can be added or subtracted or multiplied, they follow all the same properties of real numbers. So we can do things with parentheses. We can do things with switching the order of the addition. Distributive property applies to matrices with addition and subtraction. Okay, so in this example, it says 2 pet stores sell both dogs and cats. Sales from each store last month and this month are shown with this little arrangement, all right? So what I'm going to do is I'm going to write a matrix or show a matrix for each store to organize it. And it's going to be a 2 by 2 matrix, okay? So this is going to compare dogs and cats in store 1 and store 2. So I'm going to do I'm going to do a matrix for last month and this month. So this first matrix, last month, we're going to call that matrix A. I'm just going to use A for last month. So last month, and I'm going to kind of label this store 1 and store 2, row 1, row 2. My first column is going to be dogs. My second column is going to be cats, all right? So the first matrix would be, 42 and 56. So dogs sold from store 1 in this month, 42, from store 2, 56. And then cats, 33 for store 1 in this month, and then 21 for store 2 in that month. Store B, or the second store, I'm just going to label it matrix B, okay? And I'm going to use the same kind of formula. It's going to be 36 dogs, month 1, 51 cats, month 2 for this store 1, and then 48 dogs and 37 cats. So if you want to still label it 1 and 2, dogs, cats. And then we want to find an average of the monthly sales, okay? So you find the average, basically, of each element. So what that would show is I would add the values together and divide it by 2. So my first top left element, it would be 42 plus 36. So 42 plus 36 is 78. And then 78 divided by 2 is 39. So I took the average of these two elements, okay? Added them together, divided by 2. In the next element, 33 and 51, I add those together. That is 84. 84 divided by 2 is 42. Okay? And then the next one, 56 and 48, that's 104. The average of that would be 52. And then 21 and 37 would be 58. 58 divided by 2 is 29. Okay? So what this shows is, this 39 shows store 1 sold an average of 39 dogs and 42 cats. Store 2 sold an average of 52 dogs and 29 cats. So that's a way to organize information, organize values. That's what we use matrices for. So our last example, example 4, solving a matrix equation. So this kind of has a lot going on, but it's about knowing the equations you can set up to solve. So what I'm going to do is I'm going to highlight elements that kind of line up. 3x, 1, and -8. And then different color I'm going to use I'm going to line up, with the variable, negative 2y, 6, and 0. Those are all in corresponding positions. So my equations I'm going to set up, it's going to be 4 parentheses 3x plus 1 equals negative 8. So that's me applying the distributive property and then just lining up each of the proper elements. All right. So in the next part, I'm going to do next equation, 4 parentheses 6 minus 2y, and that's going to equal 0. So then this just becomes an equation for me to solve. So this is 12x plus 4 equals negative 8. If I keep solving this, 12x equals negative 12, x equals negative 1. So that's just me solving it once I've got the equation set up. For my other equation, if I distribute, this becomes 24 minus 8y equals 0. This will become negative 8y equals negative 24 if I subtract 24 from both sides, and then y equals 3. So it's just knowing how to set up and solve those types of equations. So just make sure you line up all of your corresponding elements that matter. The other elements don't really factor into the equations here, but it's applying that distributive property in this case. Okay. So now you're ready to move on to the practice. Take your time on the practice. Let me know if you need help, and then once you're ready for the checkpoint, you'll find that in the next step.